Okay, sounds good. All right.
Yeah.
Should be recording now.
Okay.
Cool. Everyone can see my screen okay?
Mm-hmm.
Okay, cool. So today I'm going to talk to you guys about text summarization here. Okay. I assume that this is going to be a pretty big part of our stack inside the Gaia product. So I wanted to give everybody an overview here, as this is a bit more complex and significantly well less studied as a topic area in NLP, especially with regards to BERT. I want to make sure we're all on the same page and we have all our questions kind of answered, so we can all kind of row in the right direction. Okay, so what we're
Mike,
talking
may I
about.
ask, you prepared the slides for what? For this show? Or
Yes,
for
for
the
this.
Other? Wow.
Yeah,
And
I
you
put
thought
the,
you were talking?
Yeah. I wanted to. I
Oh.
figured this would be easier to keep me. It helps keep my thoughts organized, and I have a slide deck.
Oh, lovely, lovely. Thank you so much. Okay. We're
Yeah, no
all
worries.
ears.
And I'll make them available after here. I probably need to beef it up. It's a bit short. But there's three kinds of text summarization right now. There's extractive summarization, abstractive summarization, and a hybrid summarization, which is going to be a combination of the two. Okay. Now, this matter. This may seem like a semantic difference between these things here, but based on how we compute our evaluation metrics, this will matter a lot, because as we'll see, it has to do with essentially Jacquard similarity in an intersection over union for a reference summary versus machine-generated summary here. So the tokens that the machine is allowed to use will have a huge difference here in what we're able to measure. So let's say I have this target sentence. Authorities are still scrambling to find leads in a bank heist. On Monday, March 31st at 3 p.m., two men robbed the First National Bank on 4th Street. They stole over $500,000 and escaped in a red F-150. So if we were going to use an extractive summarization model, then what it's essentially able to do is it's allowed to think of it as like it has scissors and glue. It's allowed to cut out pieces of sentences and glue them together. Now, as we can see here, you can kind of look up from the extractive summary and you can see where every phrase or subphrase came from in that, right? So we see on Monday, March 31st at 3 p.m., two men robbed. I shouldn't say stole, I should say robbed here. Oh, no, it has stole. That's fine. So it jumped a bit there. I just wrote this. I don't know why I'm confused. From First National Bank and escaped in a red F-150, right? So we can see where that's coming from. It's basically looking, and the model is evaluating what tokens, what engrams here are most important here, and it's gluing them together. Now it's done in a skipgram format. It does not have to be in the same order, right? So, and it would still be considered an extractive summary if it started with two men stole $500,000 from First National Bank on Monday, March 31st. Yeah, that would still be okay. Sometimes the model will still output things like that. The order isn't what matters. The tokens are. Now, an abstractive model can do some interesting things too, because if I had to guess, I'm betting this is where the field is going to go because of what we can do with embedding spaces, representational learning, a la Word2Vec and BERT, right? So abstractive is allowed to use tokens that aren't in the corpus, but it knows it would be a good fit for that otherwise here. So if you'll notice here in the abstractive summary, it says bank robbers stole $500,000 from First National Bank on 4th Street yesterday at 3 p.m. They stole $500,000 and escaped in a red truck. Nowhere in the target sentence does it use the phrase bank robbers or red truck, right? But that still makes semantic sense to us here. It still is a valid representation. And sometimes when you unblock the model from constraints like having to reuse tokens that it found in the corpus, then it is able to come up with maybe more concise or more accurate summarization strategies here. Now, a hybrid one is allowed to do both, right? Essentially, it's going to do extractive and abstractive at the same time. It's mainly going to stick towards pulling extractive summaries over here, but when it needs to, it can use other words. Now, this is not without its challenges here, right? Because once you allow the model to, once you kind of unconstrain it, and it can now use any of the words it knows here, well, then obviously there's a lot more edge cases we can run into where it might mess up, right? So let's talk about how BERT-SUM works, okay? And then I do have a demo. I ran the BERT-SUM model inside the Transformers library on about 100 Daily Mail or CNN articles. And I want to show some of the issues we're going to run into here, just so we can start thinking about how are we going to solve these challenges? Which of these are challenges that we have to solve for the customer, and which of these are kind of acceptable error, right? What are we okay with here? The best in the game right now looks like it is BERT-SUM. It's by an independent researcher named Yang Liu. He's published a paper on arXiv. You'll find the link there. The papers, I think, came out March 2019, so it's almost here. And there is a working implementation of BERT-SUM inside the Transformers library, which I'll show you all how to run once this ends. So essentially, Yang Liu had to make some architectural changes to BERT in order to fine-tune it for text summarization. One of the first things he did here is he realized, well, BERT worked off of, basically sequence 1, sequence 2 type trainings here, but sometimes you're going to need this thing to look at multiple, n different sequences in a row in order to get a good summarization. So the first thing he did is he modified this to deal with interval segment embeddings by essentially adding multiple class separators. So normally you have a CLS and a SEP special token in your data set here. So as you would feed this into the model. So what he did is he went through and he added multiple CLSs and multiple SEPs here, right? And this is going to get fed into the model. So before in vanilla BERT, each data point that it would get, right? And each combination of that and labels here, it would see the CLS token once and SEP token once here. It would basically say this is where sequence 1 starts and ends, where sequence 2 starts and ends. Figure out the relationship between these.
So Michael, do I understand that right? He has the text broken down in paragraphs, but he wants sentences. So for that, he adds more CLSs, the token separators, right?
Yes, that's correct. That's correct. Because essentially what we're trying to get out here could run the gamuts of, anywhere in that paragraph, that story, that whatever, right? So we're going to basically add a bunch of them here, and he goes back and forth. He basically labels them as A or B, right? So you still had, in the original BERT, you had sequence A, sequence B, right?
Mm-hmm.
And it would learn that one follows the other while also learning the masked language model.
Yes. What I'm thinking about is in our work, and you remember the demo you did, we would break the documents into paragraphs. If we had to use sentences, we'd have to redo the whole work. He would not have, right?
So this is an automatable process. This is something that you can pre-process and automate pretty easily here. Where essentially where we're going to insert these things here, you're just looking out for periods or question marks or things like that, and inserting them. So that is a very reachable task here if we have to pre-process here. Yes. But I am getting to where I understand exactly the question you're asking, Mark, here. I'm going to get to that in about a slide here, if you don't mind.
Okay.
Cool. So what we're looking for here is we have the original BERT here, and then it does, they do tack on some summarization specific layers. The white paper does a decent job of going into what those look like. It uses some, like he'll try it with a classifier, he tries it with an LSTM model. He uses some things like per gate layer normalization in the LSTM. But it's just a bunch of little tweaks to see what came out best. And we can, and his numbers are good. They do work well here. So this is a good starting point for us. And again, the Transformers library does contain a working implementation. I will show you all how to run it. So we can start immediately testing on just the off-the-shelf version of BERT-SUM contained within the Transformers library on our data set. We can start to figure out what are the subject-specific challenges we're going to have working with papers from a legal domain. And the sooner we can start actually testing these things, the sooner we can start coming up with solutions and kind of making progress. So essentially, as we move through here, it's important to understand what our metrics are. There are several different metrics for text summarization. The one that everybody seems to be using is Rouge, right? So you'll hear Rouge N, Rouge 1, Rouge 2, Rouge L. All that number is talking about there is the number of the n-grams, right? So Rouge 1 is it's a unigram overlap, right? So single tokens. Rouge 2 would be looking at the overlap in bigrams between a machine-generated summary and our label, which is a human reference-generated summary. So one thing that you might realize here is there are edge cases where the model might be incentivized to include n-grams or phrases that are not useful, right? Just to get that up, right? So how do we avoid phrases like insofar as that doesn't add any value. It doesn't add any actual informational content, but it would make that Jacquard similarity, that intersection between our model output, our y-hat summary, and our gold summary, our human-generated summary here, it would make it look on paper like those are better. So one thing they try, one technique is trigram blocking. So essentially, if a trigram exists anywhere in the summary, that trigram phrase cannot be used again in the summary here. And that's a way that it kind of disincentivizes redundancy here. Now, this is not a well-studied area. There's a lot of work that's been done on text summarization overall that we can read, but in terms of using transformer models, there's not a lot of papers out about this sort of stuff here. I found about 3 so far. One of which is this one, which is kind of the landmark paper on using BERT and transformer models for text summarization. And then others that are asking more detailed questions like, okay, how do we deal with controversial topics, right? So let's say I have a data set and I have competing things here, or maybe competing phrases. Let's say it's something that is interviewing, in politics here. But let's use the Mueller report example we're talking about here. If there were quotes in there from the Trump campaign and then quotes from the Mueller report itself here, what's the model going to take as kind of gold? What's it going to take as ground truth, right? So figuring out how to get it to figure out what to give back when there's controversiality present in a text is a much larger topic I'm currently preparing to talk on here, because I would assume we're going to run into that a lot in the legal sphere as well, right? If your entire document dump has both stuff from the defendant and the plaintiff here, then we can expect to see multiple viewpoints on certain important topics here. I would argue that the more important the topic, it's likely that the more controversial we'll see, because this is what the case will hinge around here. So we'll have to figure out how to get past that here. However, there are some good places to start.
In fact, Mike, Matt Riggs suggested this as initial use of Mueller report. He said, let us also crawl all of the news and then let's say Mueller report against the news media.
Yeah, I think that'd be excellent here. That's a good place to start. Mm-hmm. So these are some questions I want us to think about here when we don't need to have answers to these today, right? But the first and foremost, I think most important question here is, where in our pipeline are we using summarization, right? Are we trying to because this is going to determine how we use the BERT sum model in our pipeline, right? So if we feed it all 500,000 documents, we're going to get one summary back that tries to hit the high points of all 500,000 documents, right? So we kind of have to figure out our level of zoom, if you will. Are we trying to summarize at the paragraph level, the sentence level, the page level, the document level, things like that here? And then we also need to think about essentially what we're trying to build is a semantic search engine, right? We're not just building a summarization engine here. However, I would assume that we're going to use our summarizations to both add value to the client so that they don't have to read the entire document, but also probably to make these documents more easily searchable and indexable. So I'd in the coming weeks here, I'd like to play around, or the idea that we play around with some ideas like generating summaries and using those as vectorizing those and putting them in embedding space here, and maybe that might make it almost like with the same idea as a doc effect. Then we could use cosine similarity to pull up the top 5 areas or something like that.
Are you saying for the smoking gun, don't work on the raw text, but summarize it first?
No, well, so it depends, right? I'm wondering here, we need to play with this here. I'm saying it's an open question because if we're going through all 500,000 documents, that's a lot. You know, so with summarizations here, what we're trying to find out is what is the gist of these pages and which of these are kind of in spirit closest to what the person is asking. Whereas, you know, a keyword search could talk about, you know, for instance, the Carter Page example. If there's 30 pages about talking about Carter Page's sentencing, that's probably not what we're looking for in the example we have in the demo, right? So we would want the question to tag on to the meaning of what we're saying here, which is probably going to align very closely in a summarization. I would assume we wouldn't lose that information, you know, that it wouldn't be that lossy.
Yes, I feel this is more for the technical manual analysis use case than for the smoking gun.
Sure. I think it could do both here, right? It depends on what we're trying to do and what I think this is still a good question here is that I'm not sure what our workflow looks like. So a client types in a question and we have our demo, but what's getting processed when, what's being searched, and what are we giving them back at any given point here, right? Are we just giving it to where they can answer questions? Or for instance, like if assume you're a new lawyer being onboarded to the Mueller campaign. Maybe you've never heard the term Carter Page. How do you know to search for these sorts of things? That's obviously the challenge we're trying to solve with Skya. But I would argue that there are probably value in pulling out things like named entities, letting them know who the major players are in certain things here, giving them, maybe they want summarizations of certain documents, certain pages, certain paragraphs, like that. So they may want these things at different levels.
They may, and that will all come up. It's wonderful that we'll have those tools. The practical use cases right now is just one, and that is smoking gun. He will be looking for exactly that same thing that he gave us, but in different words.
Sure. So I guess what I'm trying to say here is with smoking gun, we're trying to then go from a question answering thing to just pointing them at that specific part of the document, or are we trying to generate a summary as well?
Yes, and then we don't even generate a summary because for the lawyers, they need just exactly the evidence that the guy said it rather than a summary of what he said.
Okay, cool.
But I think the summary would be useful, right?
It
because
would be, yes.
One thing, the way the summary would be useful is if you have documents, right, and then you're finding similar documents, like just practically from the UI perspective, having a very brief kind of abstract about the contents of the document would be helpful, right? Because the document name might be something totally meaningless, right? But, you know, if they had some kind of document there that says, we found this document number, blah, 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 which who knows what that might be. But then if they had a short summary of especially of the relevant portion of the document that we're searching for, then I think that would be very useful from
so that's as an additional part when we deliver the smoking gun. Also give him a summary.
Yeah, sure. Saying, right? This is excellent. This is exactly the type of conversation I was hoping this would foster here. Is we can kind of figure out what that use case looks like here. So what I'm trying to figure out here is for our MVP, what is our target and what is our model? Is it a question answering model? Is it a text summarization model? Is it basically vectorization and AI thrown on top of Elasticsearch? What is the most baseline product we're trying to build right here and deliver for an MVP?
Well, I think as we've described it so far as the kind of smoking gun use case, basically the idea is that this kind of semantic similarity model, right? So the idea is that so we already have an e-discovery kind of product, right? And so they can load and manage documents. So the smoking gun use case is basically to say, okay, so, we found this, portion of this document here, which is the so-called smoking gun. So let's go ahead and try to find all other documents that have something similar to that, semantically similar. Obviously, we understand that, right? So, so that's, and then I guess the way the service would then work is the way I'm envisioning it anyway, is it's basically a web service. So then once that document is provided, then at that point, we do whatever, a Jacquard similarity or whatever we do. Although actually, I think there's some other ways I'm looking into that might be better than Jacquard similarity, but whatever we do. So then we come back with a, kind of a list of similar documents with the portion of interest particularly highlighted. Also, I think the thing is that usually in this e-discovery use case, from what I found so far, Mark knows more about it than me, but the names of the documents are not very meaningful usually.
Yes.
Right. So a lot of times they're just like a number or some kind of file name, right? Yes. Document number 5,460. Right. So having a summary in that would be useful, actually, just because it would help kind of say kind of what we're looking at. So, and so I think that would, so the web service, I could see it would come back with, when we list a similar document, it would come back with the identifier of the document, maybe some kind of summary of the document, as well as the kind of basically the highlighted portion, like we were showing in the demo, of the part of that document that is particularly the one that is the one that has that degree of similarity. So
sure. Excellent. That's very helpful. The thought process I was having here is what happens when a lawyer asks a question where the answer to that question spans over pages necessarily. It's maybe not concise.
Well, that's a good question. Yeah, that is a good question. That part of that's what we're trying to do, because in a demo we showed examples where basically a small snippet of the document essentially contained the answer. But if we're saying something like, "Did President Trump break the law by meeting with a Russian Russian lawyer in Trump Tower on such and such and such and such," right? So that would obviously not be something that you could necessarily find in a quick snippet, right? Because they're probably, the Mueller report doesn't directly say he broke the law or he didn't break the law, right? It said, well, he did this, he had these meetings and that kind of thing, right? So, so I think that is something that would be very helpful in terms of their, and that's another place where automatic summarization might come in, right? Because if it's not true that there's a highlightable place in the document that we're looking for, then maybe, we would want to actually return some kind of summary rather than, essentially a quote, right?
Yeah,
so,
sure. That's what I was wondering here is, let's say that the more unconstrained the question, the harder it is for us to target, an exact phrase. I can assume that, through a significant, population of questions a lawyer might ask, something like, did client X break the law? Right. Well, if you got 500,000 documents here and half of them are from defense and half from prosecution here, that's going to return a lot of things here. So we need to make sure we're either returning the right one, or figuring out how to. Maybe there's 20 ways they broke the law here, right? So
breaking the law, of course, is probably in a way that question may be broad enough that realistically it may be difficult for us to answer that. But something maybe a bit more constrained, like did President Trump solicit election interference from the president of Ukraine, right? So that might be a bit more specific and something that we could potentially more realistically try to find some documents.
And they won't be asking, did he break the law? That's what they will be deciding in their minds.
Right. Yeah. So.
Sure.
So I think,
but a more constrained question might be something like, what evidence is there that that Trump knew? This might pull up constraint. You're going to have Carter Page, Michael Flynn, George Papadopoulos, all these different things come forward here. So we would need to figure out: are we returning all of those? Are we force ranking those? Are we what specifically are they getting back? And how are we controlling the order in which it shows up here? Do you understand where I'm coming from here?
Yeah. I do totally understand. Yeah,
this is a very interesting question that I'm looking forward to.
This is a very interesting question, and we're starting to get into activity now where I think if we are able to kind of create a product that does this, we are definitely getting activity right now that I don't think there are a lot of other people in the market that are able to do questions like that, at least not in this space, right? So I think it is a very interesting thing, and it's a high goal for us to have. I think, obviously, I think though, we obviously want to have a differentiator because types of queries that like currently in Elasticsearch one could do obviously we already have Elasticsearch integration in free. So that
Yeah.
part isn't really anything special, nor would any of our clients be too impressed by that.
Yeah.
Right. And so, however, if we can then integrate that with AI Advisor and have a much deeper level of question, then I think, yeah, I mean, I think that would be very compelling. And I think, yeah, so it'd be compelling from a market perspective. I think from an AI perspective, if we can pull it off, I think it would be something that would be good, because I think if you look at other kind of document sort of query type engines that are out there, you know, they are well, let's just say they can often very easily confused, right? So
Yes.
yeah,
Yes.
yeah.
So I'll actually show a example of how easily you some of these models can get here. As I'm trying some of these things here, but one of the things that I want us to think about here is what's the baseline level of quality here, because in that we have to compete against. Because in when I was doing the brief competitor analysis slide deck, out of the 10 e-discovery startups that I found, at least 4 talked, shot them from the rooftops that they're powered by AI, powered by deep learning. So I would love to see what are they doing, right? Maybe if it's us getting trial licenses for them, or going through product demos or something like that.
Well, one thing to say about that is I would be crazy if anybody in the space is not trying to pursue deep learning as a mechanism. I mean, if they're not doing, I would kind of wonder about these other 6 then. Like they're not doing anything with AI or deep learning. Like, what are they thinking?
Yeah,
so
absolutely.
The fact that I have 4 of them doing deep learning, to me, doesn't really say much, except for, well, duh, of course they are. And if they should check that, have their head examined if they're not, So, yeah.
I would agree with that completely. Yeah. Yeah,
right.
Cool.
Of course, deep learning is a broad subject, right? So there's a lot of different things one could be doing with deep learning, for sure.
Sure. I guess what I'm meaning here is, what is their baseline level of quality that they're putting out right now?
That's an excellent question. Yeah.
Yeah. So, and how can we make that, we're trying to figure out where is our MVP going to fit? Are we trying to match that? Are we trying to beat that? And what does that look like? What are we trying to, maybe they do, visualization of documentation, something like that. Well, that's probably not something we're going to try and compete on. So what are we worried about, and what aren't we worried about getting very good at very quickly? So one thing I will show you guys real quick here, just to make sure that everyone is on the same page, is that you can run these summarizations on your own machine. I think the next step that I'd like to do when I'm having some fun here is to start trying to summarize some legal documents and things like that here, and see, does this pull out the right thing? Now, you'll notice that this does on its surface level, it does a decent job until you actually read this. And then you realize that deep learning gets the highlights, but it gets some of the information wrong, right? Bella Rodriguez was not 51 when she was diagnosed with cancer. She was 10. And she did not astound doctors to recover from the illness. She died. This whole story is about her dying and LeBron James wearing the sneakers. So it says she was diagnosed, she got better, and then she lost the bout, right? So the challenge that we're going to have if we have to do any sort of NLG, natural language generation, and I think we should try and stay away from that as much as we can here. This is a form of NLG, and we want to limit our exposure to it being wrong. Is it can summarize and get all the main points, but put them in the wrong order, or get the semantic meaning behind certain phrases wrong here, and mix up some facts, and suddenly we're getting like incorrect information, right? Which may be incredibly harmful. So I do want to make sure that I'm clear on everybody here. I do not think this is a solved area. I do not think that this is necessarily our MVP or something like this here, but I would be surprised if it doesn't end up in our stack somewhere at some point here. So it is an area where we're going to have to be careful with what we're getting back here. So wanted to show this, but if you do want to play around with this here, you can find this within the where is it? Transformers Hugging Face, the Hugging Face GitHub here. I'll show you where this lives. So inside this examples library on Hugging Face here for the Transformers library, they have a lot of pre-built things here that are probably going to be quite useful for us here. So for instance, if we are trying to do question answering or something like that, or master language modeling, if we are trying to do named entity recognition on a document, There's sample code for all this stuff that already works. Summarization is an example.
Okay.
And it's actually pretty easy to do this, although trying to run this on my own machine, the little rinky-dinky 1060, running it on all of the CNN and Daily Mail thing told me it would have taken 450 hours. So generate some summaries if you're interested, but be careful on massive data sets.
Okay.
It's quite big.
Right. Yeah. So it's not the kind of thing that I have a 2070, so I could try running that, but it probably, because a single 2070 probably still going to take a while. Yeah. So. Yeah.
Well, and in about an hour, it put out 100 summaries for me, which is more than enough for a good test case.
Right.
See that? I'm just saying, if you follow this the summarization example on the Hugging Face thing here, all of CNN and Daily Mail is massive. It's 400,000.
Okay.
I would also recommend that maybe one thing that could be useful to us here, the Mueller report is a good document to start with here. I would probably also see if there's other legal documents we can find that we can practice this stuff on here for whatever we're trying to run back as our MVP. Simply because different text styles are going to throw off the model in different ways, right? So most of these benchmarks here, the naive benchmark for text summarization is first 3 sentences, because news stories contain almost all the relevant information you need in the first 3 sentences. I would assume legal documents do not follow that. I would assume fiction does not follow that. There's a lot of different things here where writing style is going to affect the model, both in terms of maybe what it's trained on and bias towards, and also evaluation metrics for these things. So once we know what our evaluation metric is for our given target, then we're off to the races.
Okay, good. All right. Yeah.
And that's all I've got on this topic, guys.
Okay, that sounds cool. Actually, I'm pretty excited about some of that stuff in Hugging Face. So we had originally, I don't know if you saw some of it, but we originally kind of tried our basic idea using, basically just PyTorch and nearest neighbors algorithm with that. So actually, I think this transformer that we have here with Hugging Face, this looks kind of intriguing. I think I'd like to, in fact, this week I'm probably going to try doing some of what we did before and re-implementing it using that transformer and see how that goes. So yeah, that sounds interesting. So,
Tim, if there's anything I can do to help you with that or to answer any questions, let me know. I gave Mark and Suji a talk last week on the Transformers library and Hugging Face. My guess is if you were using PyTorch before, if you were using the PyTorch pre-trained BERT library, that is Hugging Face. That's just their 1.0 implementation. There have been some breaking changes to 2.0 implementation. However, it's now platform agnostic to TensorFlow or PyTorch, which means that productionizing it, because TensorFlow is now in the game and the TensorFlow datasets library is now in the game, gets a lot easier in my experience. So I'm a huge fan of their stuff. I highly recommend it.
Okay, good.
And that was your plan, Tim, was it not?
That's
to
what
try
we had
to
on our
the
agenda this
smoking gun with the Hugging Face.
Yeah, I think actually I was using, prior to this, so we had really used that. And prior to this, I was kind of working in the background on last week on using this sentence transformer model for this. But I think actually I'm gonna kind of look at the transformer here, the Hugging Face one, and see what kind of results that we're able to get with that. So I think that's probably what I'm going to be working on this week. Yeah. So.
Yeah, it's kind of the only game in town right now, aside from the version on TensorFlow Hub, and that one is garbage. That one, in my opinion, is super wordy, and it's more for machine learning engineers than anybody else.
I see.
I wish Google would write code for people other than Google employees.
Well, I Google, what they do is they tend to kind of put some kind of great technology out there in a very raw form,
Yeah,
and it's like it's like they say, like, here you go, we got this great stuff, isn't it so cool? Yeah, it's great. It's like, yeah, that's good, It's like, but yeah, you're an engineer. I mean, you use this, So it's like that's kind of what they tend to do.
Exactly.
Yeah, so.
One of my wife's best friends is PM for the TensorFlow team, and I give her crap about it all the time. You guys just pick a style and stick with it, please. Let us build.
Yeah, that's right. All right, cool. Well, that was a great presentation. Yeah, I really appreciate
Mike,
that.
Thank you.
That definitely I think that definitely helps me in terms of what I'm working on like right now. So that'll be very helpful for me. Yeah. So good. Are Matthew and William, are you guys here?
Yeah, I'm here. I like the
Okay.
little
That's why I
summarization
didn't
thing.
know if there's if you guys were kind of there, but good. Do you guys have any questions here about this?
No. Otherwise, I just saw like that summarization thing. That was like, it's pretty cool. But I guess it's not accurate right now to actually use, or you'd have to do a lot more
Well, yeah.
testing on that.
Obviously, we saw some of the limitations of that. So those are the challenges we have going up too. Yeah. So.
I do think that for a legal perspective, if we're going to use something like this here, what might work here is sticking heavily constrained to extractive. So that way you can only use text that is in the document. And if we do have extractive summaries, then it's very easy for us to highlight where this is coming from, the document, right? The same way we saw the Carter Page memo in the Mueller report here. So just trying to right now think of different ways that we can get to that, where we can say, what are the important sentences in this document? How do we identify them? How do we highlight them?
So Mike, remember I asked this question when we started. We thought here's a document and the document is an email. Then we realized no, break the document, each document into paragraphs, but for your purposes, keep who is who, which paragraph is out of which document, and then do your model based on paragraphs. You were telling us that there is a way to somehow make it flexible.
Yes. So it looks like what Yang Lu found is that all you really need to do is modify the way the data gets put in, right? So by adding, I'm not sure off the top of my head, but actually trying it and beat my head against that wall for a day, how this will affect our results here. But being able to input, essentially, we're making a larger sequence, right? By adding multiple CLSs and SEP tokens. You can basically make a sequence of sequences. And in doing so, that can allow you to kind of go a lot further. There are now this doesn't necessarily mean that BERT is the best approach here. I know a lot of people are having a lot of success using Google's Universal Sentence Encoder, which is a deep averaging network. The challenge there is that the larger the text you're vectorizing, the more it dilutes the meaning, because again, it is an averaging network. So we've got a couple different approaches, I think, that are emerging here that we'll be able to benchmark.
Yes. Is that feasible to use something like the glue benchmark for our own benchmark? I think we discussed it yesterday or last time when Tim was presenting.
Yeah, that would actually, I'd love to get your feedback on that. In what way do you think glue and super glue benchmarks could be useful for us in terms of kind of helping, what we have? You think, are like, the glue data sets, and so they're very small, and they may or not always focused on the tasks we're focused on, but do you think those can be useful for us?
I would assume so. Yeah. I think that glue kind of all the different metrics they have there, glue seems like the most resilient. The challenge with NLP is that, every different challenge is a separate animal, right? It's not like computer vision, where they're all generally, one problem with, offshoots around it here.
Yes.
There's a big difference between multiple choice and masked language modeling and named entity recognition, all this stuff here. That being said, I think glue probably has the highest overlap with what we're trying to do here. We do need to make sure that it does understand what we're trying to do here. But I'm going to guess that it sounds like if we're trying to get them the important, correct information out of a document, we're going to have to probably use multiple metrics based on how we're getting this out, right? I would also encourage us to think about different value adds that are low-hanging fruit here. So for instance, this is something I was thinking about last night when I was playing around with the named entity recognition from BERT. This is a good open question for you guys or for anybody who has more experience in the legal space. Would something like being able to tell somebody, hey, who's mentioned in this document, or who are the players in the document? What are the things? Is that something? Because named entity recognition is a solved problem, right?
Yes, Mike. And it is used by some of the providers there.
Cool. Yeah, I'm just trying to think about what a lawyer is looking for here. If you give them glanceable information, what do they want in that?
They're looking for that. They're looking for graphs. They are looking for additional insights. But my question to you guys is, Can we use glue as is, but replace some of the data sets with our data sets? And how early in the process? Like right now, we want to rush to the very first POC implementation. So glue is a bit early, it feels. At which point, but glue is super important because that will give us the overall measure of quality. Our
Yeah.
quality is the most important.
Mhm.
And so far we just said about this, but never did it. So
short answer is I think glue and super glue are wonderful starting points. Simply because they're widely tested and widely evaluated. And at first, especially when we're pre-seed and we're trying to fundraise here, using accepted metrics rather than things we cooked up on our own are going to be crucial, right? Because when you do get in front of VCs, they are going to have people smell check our methodology, our code, like that. And sticking to a accepted evaluation metric allows us to speak the same language, whereas they don't go, listen, they made up their own target, they're moving the goalpost, you know, we don't know if they're so I think it's a great starting point here. And I would definitely use that as a placeholder if or until we find something better or we create something.
So in other words, March 31st is when we deliver, or before, our proof of concept that we can show to people that we can give them the smoking gun. Immediately after that, we become serious and we get glue, and we also do it in a more organized manner. Refactoring, is that what you're thinking?
Yeah, that makes sense to me. That makes a lot of sense to me. I'm still a bit hazy as to what our MVP architecture and kind of pipeline look like. Tim, I'd love to chat and pick your brain and hear about your thought process on something like this. Doesn't have to be now, but whenever you think is good here, I'd love to hear about. You clearly thought about this a lot.
Sure. Yeah. So I mean, so when you say pick my brain, like, so about which topic then?
So essentially, overall architecture decisions here. So, what are we trying to like? Are we using embeddings? Are we creating embedding space for documents? Are we creating embedding space for paragraphs? How are we computing what we should give the client? What are we giving the client? How do we identify that? Basically, all the questions of if we were going to write out a pseudocode diagram or a document to basically say, in 30 seconds, describe what you're doing and how you're doing it here. Where are we going with that?
Okay. That sounds, yeah, we can do that. Yeah, that sounds good. I think I'm definitely open to